So let me now hand over to Dr. Asif. I will not read the sort of extensive biography. You know about Asif now. So he will basically continue or start the school with the module of hydrology.
Thank you very much for coming to WIT. My name is Asif, and today's presentation will consist of my own introduction. Then I will slightly introduce what is hydrology and why it is important. Then I will slightly describe what are the different components one should look at from the hydrological cycle, and where and when we can use those different data sets, and what is its role in policy making, and at the end, like end users, how end users are using different portions of water for industrial use, for consumption, and for agriculture. I'm basically from Peshawar, from KBK, Pakistan. I did my bachelor's civil engineering from UAT Peshawar, and afterwards I did my executive MBA in project management from Princeton University, and PS and remote sensing postgraduate diploma from University of Peshawar. Afterwards, I went for my PhD to Cambridge University, which I recently defended successfully. So I'm still waiting for my degree, but hopefully we'll get that soon. I have more than 10 years of experience in different organizations like NESPAC, Irrigation, ADB, and University of Cambridge as well. So coming back to hydrology, actually what is hydrology? To make it simple for some of the beginners, it's the flow of water across and through near surface environments. So there are two main types of hydrology one can study, like one is surface hydrology and the other one is groundwater hydrology. Today's presentation will slightly describe both, but we will stick our presentation mainly after the tea break to watershed delineation, which would be kind of interest of many of you. So we'll briefly describe overall the water cycle and hydrological cycle. Most of you may be aware that water is evaporated due to sunshine or radiation from sea surface, and then it goes to the atmosphere, and again it comes to the ground in form of liquid precipitation, which is rainfall, and sometimes as snowfall, solid precipitation. And it is then used by human, industrial, and agriculture. But sometimes what happens, this solar radiation and temperature raises water is transformed from its own source to atmosphere again through evaporation as well as transpiration from the plants. Some of the water goes into groundwater due to deep percolation, whereas some water flows down near to the surface, which is known as subsurface flows. Actually, this is a diagram. I got it from another source, and in that source it was described by numbers, that what is this evapotranspiration and other things. one of the most vital variables is precipitation. It can be rainfall, and it can also be snowfall. If we talk about the Indus Basin, so snowfall and glacier melt is one of the most vital contributors to flows. We will talk about those two components later on, probably in our presentation speed. But at the moment, one should know that one of the most vital components of water cycle is precipitation. And if we look at the precipitation, it can be produced by different causes. It could be because of frontal precipitation. It could be frontal precipitation, which is produced by warm and cold masses of air. And it can be also convective precipitation when surface of ground becomes or produce more evaporation due to heat from the sun. So evaporation goes up, and that produces this convective precipitation. And the third type is orographic, when the air masses is traveled or forced to travel upslope. So that is also produced mostly in mountainous regions, like in our northern Pakistan. The first type is producing, the frontal one, is producing a lot of intensive rainfall. Particularly the other one is more, it's not intensive but prolonged precipitation, like we had a couple of days ago here in Lahore or in overall Pakistan. What are different sources of moisture? Normally, sea and ocean is the main source of moisture. If we look at the Indus Basin, so there are two main sources of moisture. One is the westerlies. We call it westerlies because these are moist air which is coming from the west to the Indus Basin or towards Pakistan, India, and Afghanistan areas. And these winter westerlies are producing most of the winter precipitation in shape of mostly in shape of snowfall at very high altitude, particularly in Murray, Sawat, Kalam, and Himalayas, Karakoram region. The other source of moisture is moisture from Indian Ocean, from Arabic Sea, from Bay of Bengal. So these moist airs are known as the monsoon moist air masses, which are coming from these seas and oceans towards the Sindh and then Punjab and then to the northern areas of Pakistan. The Bay of Bengal is, the masses from Bay of Bengal is traveling quite a long trajectory and entering into Pakistan nearly in the foothills of Himalayas. So it's most of its moisture is lost here in the way, but still it manages to produce a lot of precipitation because of orographic effect here, because a lot of our mountain regions are over here, which is the Himalayas, and over here there are Karakoram range, and just over here it is Hindu Kush range. So those mountainous regions are producing more orographic precipitation. These moistures are lost in the way significantly, but still it makes a lot of difference during summer. According to research, about 1/3 of precipitation in the upper Indus particularly is produced by these monsoon moist air masses, whereas 2/3 of the precipitation is produced by winter westerlies. How we measure precipitation? There are different types of measuring devices, and in particular, like in Pakistan, what we are doing, we are using manual measurements like PMD is doing, and there are also a lot of other devices which are automated. PMD is also using automated, as well as WADA is using a lot of weather station and automatic reading stations to measure precipitation and snowfall in different locations. So these are some pictures of different gauges, standard gauges. There are more than 500 types of different gauges according to World Meteorological Organization. But normally it depends on the precipitation types. If there is more snowfall, so we use larger fans and larger gauges compared to the precipitation. This is a typical weather station to measure different parameters in the mountain regions, and particularly where snowfall is the dominant precipitation factor. If we look at the other factor, which is evapotranspiration, so there are two bits, evaporation and transpiration. Normally, evaporation is from the surface of a land, or it could be from the surface of water. That could be a lake or any other water body. So it could be from open water, soil, and vegetation surfaces. But what is transpiration? It is basically from the plants and from trees. And how it looks like. If you look at a general kind of a schematic, so what happens? Roots of a plant absorb water from groundwater, and then it goes in from the stomata of leaves. Water evaporates, and that is known as transpiration. How much water is transpirated from the different depths of soil? So if you look at a typical plant, so about 40% of the transpiration after extraction is occurring from first quarter of the depth, whereas 30% is from the second quarter. So these are the two main quarters which produces most of the water to the plant, and then that if water is available for a plant, it can absorb from the ground, and then it can evaporate or transpirate from there. This is a typical kind of plot which shows evaporation in different regions of USA. So one can prepare evaporation, such plots or contour plots which can show or to provide a different differentiation that which regions are producing or providing more transpiration and evaporation from different regions. Particularly, it is for US, but there could be also for Pakistan and other regions of the world. This is a typical figure for to show that how evaporation occurs, and it is a lake in the USA again, from where most of the water is evaporated, and you can see the salt in the periphery of the lake. Again, if we have all these factors, so we can conclude that there should be a water balance for a watershed, which would be precipitation, which comes from the atmosphere to the watershed, and then there is evapotranspiration, which is going up again to the atmosphere, and from this precipitation, some of the water will flow over the land, some will penetrate to the groundwater, and some will go in the subsurface near to the ground surface. So and would drain again maybe to sea or to other streams in the watershed. So this is a typical one, and we will use this water balance thing later on to check the accuracy of different data sets, that whether precipitation data sets are good or bad mostly in the Indus Basin. So we will utilize this model once again when we go for the accuracy assessment. There are two terms. Yeah. Actually, what is there? Here is precipitation, which is coming downwards from the atmosphere to a catchment. And what is going out? Like it is, input should be equal to the output. And input is precipitation in sum. And the output is evapotranspiration, which is going outside from the catchment. There is flow, which is stream flow. So we can measure that stream flow, which is a product of this precipitation. There is groundwater percolation. So that is, on one hand, there is precipitation. On the other hand, there is flows and groundwater flows or percolation, and there are losses. So in sum, there are three things. And the fourth thing is changes from soil moisture. There are two terminologies usually used. One is weather, the other one is climate. What is weather? It is kind of a great thing, and climate is something for the longer time. So one should really distinguish these two things, that normally you can watch TV and you are watching TV possibly, and there would be weather forecast always. But there is another thing which is known as climate projections. That would not be forecast, because forecast is only for day-to-day or very for short-term period. And what we are doing, actually we are doing climate change analysis, and we have to do climate change analysis because we want to know what would come in, for example, in 2 decades, 3 decades, or even more. So those are the two things what one should differentiate if someone is beginner. Then what we do, hydrological model, hydrological modeling, it is kind of a modeling where we consider that water coming from the atmosphere and how it comes down and how it travels down to the far end and contributes to the sea or ocean at the end. So to model or to simulate this water movement throughout the watershed is known as hydrological modeling. And what are basic components for a good hydrological model? There are some which would be covered in these three modules. Number one would be delineation of a watershed. Number two will be hydrological data and hydrological modeling, and then how to collaborate and verify your hydrological modeling results, and afterwards how to use those results and how to interpret and how to use those in the policy making, and how to interlink with other resources. For example, if there is change in water, how it will impact the energy crisis, for example, or energy production at the end, and how will it influence the agricultural growth or agricultural demand. If we only stick to the first bit, which is the basin, the basin delineation or the basin itself provides us good information. If we only look at the basin shape, it provides us good information, and the size really matters. Like this, if there is a small catchment or a small basin, it will provide less flow compared to the larger one. So if the flows production will increase with the size increment. The shape of the basin also matters. If there is a steep slope throughout the basin, so it will provide a peak and then will reside that peak in the hydrograph. And if there is, the sizes are the same, but the shapes are only different. It's elongated and it's steeply sloped basin, so it will provide different peak compared to the flat one, and it will provide very kind of mild peak flow. So it is less prone to flood compared to the elongated one. What is basically?
Can you please explain the previous slide with some practical examples?
Probably, I could give you some of the example maybe in our next session, or maybe in next day session probably, but may not be today. I will definitely do this later on. What is a watershed? A watershed is an area which is providing water from whole of the or contribute a topographical division which provides water to a single point, which is known as an outlet of that basin. So if we look at the contour map, so one can cleanly draw a basin over the contours. If one wants to draw that which points will contribute water to a single point. So from the high elevation to the low elevation, one can sketch the diagram or the shapefile of a catchment. An outlet could be a road crossing, it could be a stream gauge, it could be a reservoir, it could be a stream, again, downstream stream, and it could be a wastewater treatment plant, etc. There could be difference in mountainous catchments compared to the urban ones. If you look at the urban ones, there is a street network, and wherever we are interested, we can kind of measure that what would be the catchment for a particular urban area. We will discuss how to delineate a basin actually using ArcGIS and digital elevation model. We will practice those, and it's not that simple as we can see in YouTube or in other videos that which shows it is straightforward. That basin delineation is only 4 or 5 clicks away using digital elevation model. But today, what we will do, we will describe what could be the discrepancies if we do it incorrectly. So after the event, we will come back and we'll continue this basin delineation. Thank you.